S. Muthukumar from Department of Mathematics, K.S.Rangasamy College of Technology. In this lecture, I am going to explain about the solenoidal and irrotational vector field. So the definitions for divergence and curl. Let F vector be a vector point function. Here the coefficients of ijk are f1, f2 and f3, which are the functions of x, y, z. The divergence of f vector is defined as dot product of del operator and f vector. That means dou by dou x of I plus dou by dou y of j plus dou by dou z of k dot product f1i plus f2j plus f3k. It is a dot product. So here we have to multiply the components of ijk. That means dou f1 divided by dou x plus dou f2 divided by dou y, dou f3 divided by dou z, which is a scalar value. Divergence measures a field's source at a point. That means it quantifies the contradiction at a point. Next, the definition is curl of f vector. Curl of f vector is defined as the cross product between del operator and f vector. The first row are the ijk components, the second row del operator components, then third row f vector components. Curl vector is a vector field function. It measures the infinitesimal rotation or circulation of the vector field around at a point. So these are the very important definitions to define the solenoidal and irrotational vector field. Now see the definition for solenoidal. A vector field is said to be solenoidal if its divergence is 0. That means div f equal to 0, then f is known as solenoidal vector field. The example for solenoidal vector field is del dot b vector. Here b is a magnetic field vector, is 0. This solenoidal vector field lines form a closed loop. There is no sources or sinks in the solenoidal vector field. Next, define the irrotational vector. If curl f equal to 0, then the vector field is known as irrotational vector field. That means there is no rotation in the vector field. The example for irrotational vector field is electric field E. Due to stationary charges is irrotational. That means del cross f vector equal to 0. Next problem based on these vector fields. The first problem, show that f vector is a solenoidal vector field. So we have to prove that del dot f equal to 0. That means take the dot product between del operator and f vector. That means dou by dou x of I plus dou by dou y of j plus dou by dou z of k dot product of f vector x plus y into I plus y minus z 3z into j plus x minus 2z into k. So here multiply the components of I into I, j into j, k into k. So the remaining components are 0. That means I into j, j into k, I into k. These components are 0. Now the I into I form dou by dou x of x plus 3y. So differentiation of x plus 3y with respect to x. So this is 1. For the second component, dou by dou y of y. So differentiation of y equal to 1. While differentiating with respect to y. Minus 3z is a constant, so its corresponding differentiation is 0. For the third term, dou by dou z of x minus 2z. That is 2z differentiation 2. So 1 plus 1 minus 2 equal to 0. That means given f vector is solenoidal. Then move to the second problem. Find a vector A such that 3x minus 2y plus z into I plus 4x plus ay minus z into j plus x minus y plus 2z into k is solenoidal. Here the given vector field is solenoidal. So using this condition we have to find the value of this constant. For that use the definitions for solenoidal vector field. Del dot f equal to 0. This dot product of del and f vector equal to 0. Take the dot product. So here the differentiation dou by dou x of 3x minus 2y plus z equal to 3. The second differentiation dou by dou y of ay equal to a plus third component multiplication k into k dou by dou z of z 1 means 3 plus a plus 1 equal to 0. From that we can find out the value of a. Here a equal to minus 4. So when a equal to minus 4, the vector field is solenoidal. Next one, show that the vector field f equal to 2xi plus x square plus 2yz plus y square plus 1 into k is irrotational. There is no rotation in this vector. So we have to prove that. For that we have to find out the cross product between del and f vector. Here del cross product is defined as the determinant of ijk, then del operator and f vector. Now take the determinant on the above equation. So the first one, I into dou by dou y of y square plus 1. That means 2y minus dou by dou z of x square plus 2y z. That is z term differentiation 2y. I into 2y minus 2y minus j into cross product of dou by dou x into y square plus 1 minus dou by dou z of 2xy. So its corresponding differentiation terms are 0. Then k into dou by dou x of x square plus 2yz, which is equal to 2x minus dou by dou y of 2xy. That is differentiation of 2xy with respect to y, which is 2x. Now check the component of each term. 2y minus 2y 0, 0y minus 0, 2x minus 2x 0. That is del cross f vector equal to 0. Therefore the given f vector is irrotational vector. So these are exercise problems.